The determinant in quadratic equations is a really useful tool for figuring out the number of solutions that an equation has. So what we use to denote the determinant is the symbol delta, which is pretty much just a triangle, but it's equal to b squared minus 4ac. Now, a, b, and c just come from our normal quadratic form. So if we have y is equal to ax squared plus bx plus c, then a is the coefficient of x squared, b is the coefficient of x, and c is just the constant on the outside. So delta, or the determinant, is equal to b squared minus 4ac. So we can calculate this determinant, or this delta value, and then depending on what value it is, it's telling us a different type of condition when it comes to the solutions that we're finding. So for example, if we find the determinant and it's negative or it's less than 0, then there's actually no solution to the equation that we're solving. If delta is equal to 0, that means you have one solution, and if delta is greater than 0, that means you have two solutions. So let's just make up a really basic example. Let's say we have y is equal to x squared plus 6x plus 3. And this is not easy to factorize because we don't have numbers that multiply to 3 but add up to positive 6. But what we can do is determine if it actually has solutions in the first place by finding the determinant and seeing which one of these conditions it falls under. So what we do first is we've already got it into this form, ax squared plus bx plus c, but just keep in mind that because we're trying to solve for the x-intercepts, we make this equal to 0. And now we can find the determinant, which is just b squared minus 4ac. So b squared minus 4ac. So b is equal to 6 in this case, so it'll be 6 squared minus 4. A is 1 because there's just no number outside of the x squared. And then c is equal to 3. So we're integrating 6 squared, which is 36, minus 4 times 1 times 3, which is 12. This is equal to 24, which is positive. So our determinant is positive, therefore we have two solutions to our quadratic equation. So we can just say, therefore, two solutions, or in this specific case, two x-intercepts. Now, in this specific case, it was two x-intercepts because that's what we're actually trying to solve for in the first place. But keep in mind that the determinant is not specifically for x-intercepts. It could just be any quadratic equation that we're trying to solve. So we'll go through an example in the next clip where we go through solving a simultaneous equation where we end up getting a quadratic, but the determinant tells us the number of solutions, not the number of x-intersections. So here's a set of simultaneous equations where we have one quadratic and one linear. So when we combine these two equations together, we end up getting a quadratic equation, because what happens is we let equation 1 equal equation 2, and therefore you get a quadratic is equal to a linear, and that just ends up being a quadratic equation that we're trying to solve for. So what we do is we say 1 is equal to 2, so therefore x squared minus 5x plus 6 is equal to 2x minus 6. So then we'll move everything to one side, just the same way as we always solve a quadratic equation. So move everything to one side, we end up getting x squared minus 7x, and then 6 plus 6 is equal to 12. That's equal to 0. So now we have this equation equal to 0. In this step here, this is where we use the determinant to determine how many intersections we have. Because we couldn't do it before because we don't have everything on one side. But now that everything's combined and everything's to one side, we use this equation that we'll get our solution with, and we'll use a determinant on this one here. So what we do is we say determinant is equal to b squared minus 4ac. So it ends up being negative 7 squared minus 4 times a, which is 1, times c, which is 12. So negative 7 squared is positive 49, minus 4 times 1 times 12 is equal to 48. This is 1, which is greater than 0. So our determinant, again, is greater than 0. So therefore, we have two solutions to our equation. But in this context, it just means that we have two solutions or two intersections to our simultaneous equations. So I'm just going to say two intersections here. Cool. Now, we could just solve the equation equal to 0 and determine that we have two intersections as well. But what this actually does is, if the equation is complex and it's too hard to solve, what this does is just confirms that we have solutions or don't have solutions, so we kind of know what result to expect. In this case, it would actually be pretty easy to solve because we can factorize this as x minus 3, x minus 4. But in a lot of cases, when you're solving simultaneous equations, the solution is not going to be as easy to find. So it might be a really complex equation with all these random numbers that you can't kind of figure out factorizations for. So this is a good first step to take if it is complex, because let's say if you solve the determinant and it ends up being a negative determinant, there's actually no point trying to find solution because there are no solutions. Or if there's only one solution, you might use a slightly different process for trying to determine the solution. So this is the good thing about determinant. It will tell you the number of solutions, or in this case, the number of intersections, without actually having to do the equation and solve it yourself.